This video introduces a usage scenario and a case study to demonstrate Trasculptor. Building a new road may unexpectedly worsen the traffic system. An example is the Breas paradox. In this scenario, we use an illustrative road network that is widely used to showcase the Breas paradox. There are 5 roads. Roads 1 and 4 are very wide for many vehicles. Roads 2 and 5 are normal. The road 3 is wide, and vehicles can be very fast. 1,000 vehicles from the left node need to go to the rightmost node. Each driver can choose 3 paths. First, we can analyze the traffic simulation result on the map. Roads 2, 3, and 5 have wider edges, indicating most drivers choose this path. However, roads 2 and 5 have long travel time because of heavy traffic. In the origin, if some drivers choose the road 1, it will alleviate congestion on the road 2. But the road 3 attracts a large number of drivers to the road 2. After inspection, the other 2 paths take 13.6% more time than the current path. So, no selfish drivers are willing to switch their paths. Then, we remove the road 3 and obtain the new road network. The remaining roads have similar widths, indicating that traffic demands are evenly distributed between the 2 paths. Vehicles on both paths have the same travel time, and drivers do not prefer one path over the other. We can see the status changes of the 4 roads. On the one hand, the traffic volume on roads 2 and 5 decreases, and the travel time decreases significantly. On the other hand, the traffic volume on roads 1 and 4 increases but is still below capacity. Vehicles on the roads can quickly pass through the roads. As a result, the network has been improved with 26% improvement. In this case study, we invited 3 domain experts to focus on the Sioux Falls network and analyze the system's effectiveness. After the expert fed the dataset, inner roads appeared mostly yellow, orange, or even red, but outer roads tended to be green. The expert noted that the center of the area was busier. Many vehicles passed through or headed there. He was particularly interested in identifying the most congested roads. By double-clicking on these roads one by one, it became evident that many trips between the southeast and northwest areas passed through roads 16 and 19 and caused congestion. First, the most straightforward countermeasure is expanding or improving these 2 roads. The expert initially increased these roads' width to 1.5 times their original width. After modifications, widened roads turned orange at once. However, this countermeasure only led to a 4.5% improvement. Moreover, the improvement mostly comes from the 2 modified roads. Specifically, the expert filtered the roads with large changes in the travel time and obtained only the 2 roads. He also filtered the road with large changes in the traffic flow, and only 4 roads were left. Recognizing that expanding individual roads only scratched the surface, the experts sought alternative options. Inspired by the visualized OD demand, the expert tried to build new roads. By dragging from one intersection to another, he built 3 additional roads between the southeast and northwest areas, aiming to alleviate congestion on the roads 16 and 19. These 3 modifications were denoted in P1, P2, and P3, corresponding to the 4th, 5th, and 6th nodes in the history tree. The expert found these countermeasures promising and aimed to choose the most ideal one. To compare the 3 modifications, the expert deselect the 2nd and 3rd columns. The expert filtered these roads by adjusting the range on the histogram of the traffic flow ratio and ranked the roads by the scope of the traffic flow ratio in descending order. Then the expert obtained the top 12 roads and tried to do deeper analysis. First, the expert decided to analyze the 2 most congested roads. For illustration, we denote expanding of roads 16 and 19 as P0. On the 2 roads, P1 led to the largest improvement, followed by P2, and then P3. The expert explained that the new roads in P1 were closest to the 2 roads, serving their travel demands. The improvement caused by P3 was comparable to that caused by P0. The expert said, building new roads can provide comparable improvements to P0 on roads 16 and 19, and have a more positive impact on the road network than improving a single road. Besides, the expert analyzed the impacts of P1, P2, and P3 on other roads. P1 negatively impacts roads 17 and 20, roads 11 and 9, and roads 47 and 22. These roads were directly connected to the new roads, resulting in congestion as most of the traffic flow needed to pass through them. Particularly, roads 17 and 20 and roads 47 and 22 already tend to crowd as their edges were orange. P2 had negative impacts on roads 11 and 9 since the new tunnel attracted some traffic demands. The glyphs below P3 were green, indicating that P3 improved all these roads. Finally, the expert chose P2. First, the construction cost of P3 was the highest as the tunnel was long and went through 2 roads. Second, P1 will make some roads that are already unobstructed more unobstructed. Third, although P2 had a negative impact on roads 11 and 9, the traffic volume had not seriously exceeded the capacities and the road conditions were still acceptable.